Congratulations on locating the first video lesson for the trigonometry portion of our class. This lesson is about angles, and we're first going to be talking about angles that are classified by measure. There's a little cartoon over here to the right that has a little joke of, hi, you're an acute angle, and that word acute is probably something you remember from your geometry class. This is also a little math humor. Thanks for the complement, a complement or pair of complementary angles. That's another term you might remember from geometry. And both of those we're going to talk about right now. Angles can be classified by measure by grouping them into three groups. One group, as the comic suggests, is the group of acute angles. One is the group of obtuse angles, and one would be the group of right angles. An acute angle has a measure of less than 90 degrees. A right angle, to skip down here, is exactly 90 degrees. And it's often shown in a picture with the little right angle symbol, which is a box like that. And the obtuse angles are angles that are more than 90 degrees, but less than 180. Okay, up here I actually should have said more than 0. It wouldn't be a negative number. Okay, so between 0 and 90 are acute, between 90 and 180 are obtuse, and if you have exactly 90, that is a right angle. Down here we have the terms complementary and supplementary. Complementary angles don't just pay compliments to each other like in the cartoon up here. Complementary angles are a pair of angles that add up to 90 degrees. And so that would be, this term would apply to two angles. You'd have something like 10-degree angle and an 80-degree angle, okay? So one angle by itself can't be complementary. A pair of angles might be complementary. Supplementary angles are the same idea in terms of that you would apply this term to two angles. You notice the plural. Supplementary angles, however, add up to 180 degrees. Sometimes students will get these two terms a little confused. I would suggest just, if you need a little memory help, C comes before S in the alphabet, and 90 comes before 180 if you're going from smallest to largest. And so that can help you remember that complementary and 90 go together, supplementary and 180 go together. An example over here for supplementary angles then would be, let's say, 60 degrees and 120 degrees, for example. Okay, that would be a pair of angles that add up to 180. On the next little part here, we talk about degree, minute, second versus decimal degrees. This is a little confusing. Sometimes people have a hard time even discerning which thing they're looking at. A decimal degree is going to have a decimal point in it. So if you look ahead in your notes, this number here is an example of a decimal degree because it has that decimal point. This measurement is an example of what we call degrees, minutes, seconds. This symbol is the degree symbol, that little circle. 1 dash in this context means minutes, and 2 dashes in this context means seconds. So just like in the clock, where we divide things based on the number 60, so is the case with degrees, minutes, and seconds. So I will write up here for you that 1 degree is equal to 60 minutes. So if you were to take a 1 degree angle and chop it into 60 parts, each of those parts would be a minute. 1 minute is equal to 60 seconds. You can take that even tinier sliver of an angle and chop it up even more, and you would get what are called seconds. All right? I'm going to have you look at your calculator for a second. So if you need a minute, pause the video, find your calculator. Okay, so this next part hinges on using the angle button within your graphing calculator. And so one thing that we want to check first is that you're in the appropriate mode. You will never have to change this unless someone changes it for you. The calculator will remember this as a setting. So first go to the mode key, and then in the third line there's a choice between radian and degree. And you don't want radian, you want to pick degree. After you've done that, you're ready to do these two sample problems. So suppose you have a measurement like this one that's given in degrees, minutes, and seconds. We want to convert it to decimal degrees. So all you have to do actually is just type this in exactly as it looks on the piece of paper, okay? Get yourself a blank screen on your calculator, and then you're going to hit the second key in order to select angle. So there isn't a button that says angle, it's actually on the key that says apps, and then if you hit second apps, you'll get angle, okay? Once you're in the angle menu, and you know that you are because it says angle at the top of the screen, you're going to be able to access the degree symbol, the minute symbol, and the second symbol, okay? You'll be able to access all of those things. So I need you to type in exactly this on your calculator. Type in 165 on a blank screen, okay? So now get out of the angle, type 165, go into angle, pick up the degree symbol by hitting enter, and then go back to your home screen and type the 51, then go into angle and get this mark. And then actually the second symbol is on the keyboard, okay, because that quotation gets used more often. It gets used for other things besides angles. So you're going to use the alpha key. On my calculator, it's green, but on different calculators, it's other colors. And then the plus symbol. So the alpha and then the plus will give you this mark, okay? Once you have all of that typed in, you just are going to need to hit enter. And the calculator will understand that what you mean for it to do is to convert this amount into decimal degrees, okay? So you type all of this in red, and then you hit enter. And the answer that your calculator should display is 165.8525. We know this is decimal degrees because this part here, 0.8525, is equivalent to 51 minutes and 9 seconds. It's just stated in a different way. It's stated as a decimal. Okay, to go the other direction, if you start with something that's a decimal, first job is to type it in. So type in 102.3771. You can type the degree symbol, but it's actually not needed, okay? The calculator will understand because of the next step you're going to do. You're going to hit second and apps in order to pick up the angle menu. So we'll do that. And then within the angle menu, so this is what my calculator screen looks like right now. Within the angle menu, the fourth thing down is what I want to pick. It's the little thing that looks like a wedge, and then DMS. That's saying convert to degrees, minutes, seconds. That's precisely what this question is asking us to do. And so the answer that I achieved there is 102 full degrees plus 22 minutes plus 37.56 seconds. Now, sometimes people get confused because they say, oh, there's a decimal here. This must be decimal degrees. No, it's not. You have degrees, you have minutes, you have seconds. It's degrees, minutes, seconds. All right? All right, next idea is going to be more about ways that we can just think of angles in general. We are going to think of angles as being rotations a lot in trigonometry. In geometry, you just thought about, okay, if I have a ray and then another ray, that's an angle. Angles can also be thought of as rotations. That initial side is what you begin with. So here is our coordinate plane, our x and y axes. The initial side is always right here. That side is locked into place, okay? So I didn't draw that super great, but it's supposed to be right on that right half of the x-axis, okay? That's the initial side. Initial means beginning. The terminal side is what you get from turning from that beginning part. So here's my beginning or my initial side. And then if you imagine like a little rotation, let's say it rotates all the way over to here. Here is the other ray of the angle. Remember we said angles are made of two rays? So this dotted line in here is just showing the path. This is my initial side. The terminal side is this part here. The initial side was this part here, okay? And those two parts together make up our angle. Standard position just means that we're thinking of an angle as being on the coordinate plane. Angles are made by rotating on the coordinate plane. We could write that down. I think that's a pretty good explanation, okay? When we rotate, let me think of where I put this. Oh, here it is. When we rotate this direction, that is a positive rotation. Here's our initial side over here. When we rotate this way, that's a negative rotation. So some people would call this one clockwise and this other guy counterclockwise. But if those words confuse you, just learn which way is positive and which way is negative and you will be fine. Okay? So positive versus negative, also very, very important. Okay? We have two more terms to go. One is quadrantal angles. I hope that you know that these four regions are called quadrants. This one here is called quadrant 1, this is quadrant 2, this is quadrant 3, and here is quadrant 4. If you look at the order that they're labeled in, you should see the letter C, okay? Quadrantal angles are those that land on the axes between the quadrants. So here is my initial side again. And then if I had a rotation of positive 90 degrees, for example, that would land right here in between quadrant 1 and 2. That's an example of a quadrantal angle. So examples of quadrantal angles would be 90, 180, because that would be over here on this line, right? And then 270, 360, and I could keep going. 540 would be another one, 720 would be another one. I could even have negatives with these. Negative 90 degrees would just be to go down here, and so on. 0 is a quadrantal angle. Okay, so anything that lands on the axis is a quadrantal angle. Last little point, coterminal angles. Coterminal angles are those that end in the same place. Look at this word. CO means with or together. Terminal, like if you think of an airport terminal, that is where something ends. So ending together or ending with something. That's what coterminal means. Okay, so if we were to pick a location, let's say, I'm trying to think of a good one here, I don't know, let's say 120. 120 degrees in the positive direction is about there. It's in quadrant 2. However, to get to that same location right here, I also could take this path. Now, the green arrow that I just drew indicates a negative rotation. Well, how much is that negative rotation? Well, this is 120. That red is 120. This part of the 120 is 90, right? So that means this little angle over here must be 30. Which means that this other portion of quadrant 2 must be 60, right? Remember, this is quadrant 2. And then two 90-degree angles together would make 180 degrees plus 60. Well, 180 plus 60 would be 240. So this green arc that I've drawn represents negative 240 degrees. Remember, it's negative because we went the other direction, the clockwise direction. So an example of coterminal angles would be positive 120 and negative 240. Why are they coterminal? Because they end in the same place, okay? So the definition of coterminal would be two angles that end or have their terminal side in the same place. Okay, I hope you have a good set of notes for yourself. Feel free to go back to any part of this lesson that was unclear to you and clarify your notes. Listen again, and I will see you in class.